Hello students, today we will discuss about solar and sidereal day. So solar day is very familiar for us. What is a solar day? It is the time required for sun to appear again at a particular location. And that is what we take it as a one day which is corresponds to 24 hours. There is another special day, a term called sidereal day in astronomy, which is about 23 hours 56 minutes and 4 seconds. So what is the difference between a sidereal day and a solar day? Yes, from the name itself we can see a day with respect to the sun, counted with respect to the sun, is termed a solar day, while a day counted with respect to a distant star is taken as a sidereal day. So how it can be visualized, let's see it. So in sidereal day it corresponds to rotation of earth relative to a distant star. So here you can see it has been rotating, completing one rotation, but as it completes one rotation it has moved, it has revolved. Okay, so that corresponds to sidereal day, which completes one rotation, but it has to rotate a bit more to watch the sun again at the same location. Why? Because it has moved a bit forward in the while making the revolution simultaneously with the rotation. So that is why there is an extra minutes of 4 minutes to be rotated more by the earth to watch the sun again at the same location, and hence the solar day is 24 hours while sidereal day is 4 minutes less, or more specifically it is 23 hours 56 minutes and 4 seconds. Okay, so what we have seen in the video is this. So on day 1, imagine you are standing here and you can see a sun and a distant star overhead, and sidereal day can be counted as, that is, the earth has rotated and you have observed day and night, and you are again, earth is again rotated, and distant star has come overhead again. Okay, so at that point, that time duration is called sidereal day. But you can see the sun is not overhead now. Why it is not overhead? Because earth is not rotating at the same point. While making rotation, it has moved a little bit forward to revolve around the sun. So what happens then? The sun has changed from the overhead position. So then how do you get to the overhead then? You have to rotate a bit more than one complete rotation. Okay, then sun will become overhead of the observer. So that duration of a day is counted as solar day. Hope it is clear for you. So in the first case, here you have a rotation of the earth. You are observing from the earth with sun as overhead as well as a distant star as overhead. And after one day, that is after one complete rotation, when you look overhead you can see the distant star again, because 24 hours, because one rotation have been elapsed and you are supposed to see the distant star again on your overhead. But why not the sun? Because the earth has moved forward along with the rotation, so the sun has shifted from the overhead position. So the observer now have to rotate a bit more than one rotation so that the sun is seen overhead again. So then it is called solar day, while the first one is called, with respect to the distant star, is called sidereal day. So sidereal day is taken as the time taken by earth to rotate from rotate about its axis so that the distant stars appear in the same position in the sky, while sidereal day can also be represented as one complete rotation with respect to any fixed star. Now let us have a comparison between solar day and sidereal day. So solar day, we are taking the time duration of Earth's rotation using sun as a reference, while sidereal day is by using star as reference. So solar day is what familiar for us, which is 24 hours long, and sidereal day is less than the solar day, and it is actually given by 23 hours 56 minutes 4 seconds. And solar day can be counted as the length of time between two transient position by the sun. Okay? That is time required for the sun to reappear again at the same location. While sidereal day is the time interval required for a star to cross the same position two times successive. That is time duration for watching that same star again. Okay, so solar day is, as we have seen, 4 minutes longer than sidereal day, as we mentioned, because the Earth rotates on its axis. Along with that, it moves forward in the orbit around the sun. That is why it is taking 4 minutes longer. So Earth must complete slightly more than one whole rotation in space before the sun reappear on your meridian. Okay. While sidereal day can be considered as the time requirement for Earth to rotate one whole turn in space. So it is equal to the right ascension of the star on your meridian. Okay. So now let us discuss why do we get why do you get to see rising and setting of star. That was already been mentioned. That is called apparent daily motion of a star. Why it is called apparent? Why not it is exact? Is the star that is moving? No, it is the earth that is rotating, but we are observing from the earth. We feel that stars are actually moving. Okay, and hence we call such a motion as an apparent motion. We feel so. That is why the term apparent daily motion of star, which which means that rising and setting of star or circling around the celestial poles. So these are due to the spinning of Earth or the rotation of Earth about its axis. So um, what is the reason for apparent annual motion of the star? That is, you would have noticed that the position of star is not constant throughout the month, throughout the year, isn't it? It keep on changing from one season to another, and that is due to the revolution of Earth around the sun. What do you mean by revolution of Earth? Revolution is moving around the sun, while rotation means rotating, just like rotating a coin. It will be rotating about it as well as it is moving forward somewhat, isn't it? So that is apparent, that accounts for the apparent daily motion and apparent annual motion of the star. And it is seen that a star would rise about 4 minutes earlier each evening. Why that so? We have already mentioned sidereal day is 4 minutes less than the actual solar time. So we feel that every time the star rises 4 minutes earlier. So for in a day it is 4 minutes. So if you count up to 30 days, this would be 4 into 30, which is 120 minutes. That means 2 hours. After 1 month, the star would be seen to rise after 2 hours. So for a whole year, what will happen? 2 into 20, 2 into 12, that is 24 hours. That is 24 hours means a one complete right ascension has been counted, isn't it? Right ascension, that means the vertical line which have been measured in terms of angles from 0 hour to 24 hours. So 24 hours കഴിഞ്ഞു എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ it means that the star would appear the same again after 1 year. After 1 year, the star will be at the same position. 24 hour corresponds to 0 hours, isn't it? So the starry sky would look the same again after a year. So this is what we have been mentioning, that is sometimes you feel the sun is at overhead, just vertically overhead of you, but at some other time you feel that sun is more closer towards the south direction, while in some other time you feel that sun is more closer in the north direction. You would have observed it. Actually my house is actually facing the south, and now I can feel that sun is in the north, mostly in the north. അതായത് സൺലൈറ്റ് കിട്ടുന്നത് നോർത്ത് ഡയറക്ഷനിലാണ് എനിക്ക് കിട്ടുന്നത്. ദാറ്റ്സ് ബാക്ക് സൈഡ് ഓഫ് മൈ ഹോം. പക്ഷേ കുറച്ച് കാലം കഴിഞ്ഞ് കഴിഞ്ഞാൽ ദാറ്റ് ഈസ് ടുവേർഡ്സ് ഡിസംബർ ആൻഡ് ഓൾ, I can feel that the sun is actually in the south direction, that is in front of the my house. That means you would have experienced that നമ്മൾ തുണി വിരിക്കാനൊക്കെ അഴ കിട്ടും അല്ലേ? സോ അഴ കിട്ടുമ്പോൾ എപ്പോഴും അഴയിൽ ത്രൂ ഔട്ട് ദി ഇയർ വെയിൽ കിട്ടുമോ? ഇല്ല. ഇറ്റ് കീപ്പ് ഓൺ ചേഞ്ചിങ്, റൈറ്റ്? സംടൈംസ് അവിടെ ഷെയ്ഡായി പോവും. നമ്മൾ എന്തെങ്കിലും അഴ മാറ്റിയിട്ട് ചിലപ്പോൾ ഫ്രണ്ടിലോ വെയിലുള്ള ഭാഗത്തൊക്കെ അമ്മമാർ ഇട്ടാറുണ്ട് അല്ലേ? So that is how it happens. That is the position of star will vary throughout a year. So this is what I have shown for an observer standing at the equator, and depending upon the latitude where he is standing, the position of sun or star will vary. So why that so? Why is that happening so? It is because of the apparent annual motion of sun, that is due to the revolution of earth around the sun. Okay, so you know that earth is revolving around the sun in an year, but what we feel that sun seems to move in a full circle around the earth or in the celestial sphere every year. So the altitude of sun above the horizon at the noon varies. As we have just mentioned, the sun's position or height or altitude will be seen to be varying throughout the year. Why that so? It is only because the earth is not upright. The axis of the earth is not upright. It is actually about tilted. That is, if you one might feel that earth is like here. It's not working. If I draw let me change the color. Okay, so I have sun here and I have earth here. Oh, it's not coming up. Blue is not coming up. Sorry, let me take red. It is not. Okay, it's not working. Let me take yellow itself then. Okay, for the time being, let's do with this color. Okay, so you have a sun over here. Okay, sun over here, and around the sun you have so the altitude of sun above the horizon, that you can visualize in the next figure. That is, here you can see the axis of the earth is not actually in the straight direction, but it is tilted. And how much is the tilt? How much is this tilt? This tilt is what we mentioned as 23.5 degree. 23.5 degree. Okay, so if it was exactly vertical, then you would have experienced a same season every time. But what is happening is that it is pointing always in some direction, that is about 23.5. So here you can see at this point in June, this axis is towards the sun, right? And which part of the axis? You can see here it is the northern hemisphere, isn't it? This part belongs to the northern hemisphere. So here you can see that the sunlight is falling directly on the northern hemisphere, while some indirectly on southern hemisphere. Okay, so what will be the season in the northern hemisphere? It would be summer. Okay, and hence it is called summer solstice. Okay, it happens in June. Yeah. Now, as the earth revolves, as it reaches the sun during September, this axis is in such a position. Here you can see the axis in such a position that equal intensity is falling on both the northern hemisphere and the southern hemisphere. So here also it will happen like that. The face of the earth facing the sun will receive the light equally in the northern direction as well as the southern direction. So that point is called equinox. Okay. Now as the earth revolves again and reaches a position as in the December, you can see again the tilted portion. The southern part of the tilted axis is towards the sun. So what will happen? The southern hemisphere will get more light or direct light, sunlight, while the northern part is getting less sunlight. So what will happen to the northern side? It would be winter, while in southern region it would be summer. Okay, every time we have mentioned or termed in terms of northern hemisphere, and hence you can call this as winter solstice. Why? Because it is this time of the year during which the northern hemisphere will experience winter, isn't it? So December is the time when the northern hemisphere will experience the winter, and hence the term winter solstice. Again, as the earth moves during March, you can see the axis is such a way that the sunlight falls equally on northern and southern hemisphere, and it is called an equinox. Okay, so this is the actual part of the motion, but what we experience is that we experience sun has been circulating around the earth, isn't it? So at some point you can see that the sun will be crossing the equator or celestial equator, then that is called equinox. And as the sun moves from north direction to the south direction, it is called autumnal equinox. And as the sun proceeds and comes up, again crosses the equator from south to north, then it is called vernal equinox or spring equinox. Okay, and after that you can see the sun has reached the topmost point in the northern hemisphere, and then it is called, then it means the northern part will be receiving much direct sunlight, and hence that point is called summer solstice. And once the sun has reached the highest point in the southern hemisphere, then south part will experience summer while the northern part of the earth will experience winter, and hence the name is given as winter solstice. Okay, so this is how we have explained it. So equinox is either of the 2 points on the celestial sphere where the celestial equator will be intersecting the ecliptic, which means ecliptic is the path of the sun. So whenever the sun intersects celestial equator in the celestial sphere, then those 2 points are called equinox. Okay, so equinox is also either of the time at which the center of sun's disk pass through these points. So vernal equinox or spring equinox is when the sun reaching its ascending north, in the sense it is crossing the celestial equator, moving from south to the north, and it comes on March 21st and marks the start of spring in the northern hemisphere, and hence the term spring equinox. And autumnal equinox is the same, only thing is that sun is going down towards the south. So it is happening in September 22nd and marks the start of autumn in the northern hemisphere. Okay, everything is mentioned in terms of northern hemisphere. So these are the 2 days of the year on which everywhere on earth day and night are of equal duration, and that is why the term equinox has been given. So the next term is solstice. So how do you define solstice? It occurs twice each year. It is the point of time at which the sun reaches its most northerly point or most southerly point relative to the celestial equator on the celestial sphere. Okay, so the day of the solstice has either most sunlight of the year, then it is called summer solstice, that happens when the sun is at most northern point, or it would have the day would have least sunlight of the year, which means the sun is at most southern point, and hence the northern hemisphere would experience the winter, that and hence the name winter solstice. Okay, so that ends chapter on constellation. So far we have discussed what are constellation, how to identify constellation, then we have specifically seen 3 constellation: Orion, Crux, and Ursa Major. Then we have seen how to identify and watch sky using celestial coordinates, and we have explained some of the terms as equinoxes, solstices, and so on. Okay, so that ends the first chapter, and so that's it. Thank you.